Thank you for joining today's webinar, A/B Testing in Fusion 4. Today's presenters are Lucidworks Director of Fusion AI Product, Lasya Marla, and Lucidworks Technical Engagement Manager, Andy Oliver. Thanks for joining us today, Lasya and Andy.
Thanks, Janessa. Before Lasya begins, I'd like to tell you a little bit about Lucidworks. Lucidworks is a company focused on AI-powered search solutions, both in the cloud and on-premise. The company is based in San Francisco, with offices around the world, and is relied upon by many of the world's largest companies. Our award-winning platform, Fusion, combines Spark and Solr with search-focused AI and machine learning capability, an app development framework, and insights and analytics in order to help your users and customers find exactly what they're looking for. Let's talk about our recent Fusion 4 release. Fusion 4 adds the app concept, which allows you to combine multiple collections into a single application. This includes our new App Studio web-based applications framework. Fusion 4 also adds App Insights, which allow you to get charts and reports about what users are doing in your search application. In this webinar, we'll highlight the A/B testing or A/B experiments feature. In this release, there are built-in machine learning jobs executed on Apache Spark, allowing you to perform common AI-powered tasks in your search application, such as classification, clustering, or head and tail analysis. This release adds a connectors SDK, making it easier to create custom connectors. Aside from these features, there are numerous improvements in the search engine, including scalability improvements. You can find out more about what is new in Fusion 4 on our website or from the previously recorded webinar. Without further ado, I'll turn it over to Lasya, who will tell you about our Fusion 4's new experiments feature and A/B testing in general.
Thanks, Andy. Hi, everybody. I'm Lasya, and I'm the Director of Product for Fusion AI here at Lucidworks, and I'm going to be talking about experiments today. So before we get started on the actual nitty-gritty of the experimentation setup in Fusion, let's quickly talk about what experiments actually are. Experimentation, sometimes called A/B testing, is the process of comparing two or more variants to determine which is better according to some metric. That nomenclature of variants and metrics is what we use in Fusion. But essentially, all that means is experiments are a way to evaluate whether making some change X, whether it's turning on recommendations or signals or implementing our head-tail, is helping or hurting some goal Y. For example, looking at this diagram, you can see that version B of the page is doing better than version A, according to whatever the arrow is measuring. To translate that into the experiment language we use with Fusion, this means that variant B is doing better than variant A, according to the metric being measured by the arrow, which might be something like click-through rate, for example. Now that we have an idea of what an experiment is, let's talk about why they're important. There are a million different ways to change the search experience for your users, but discovering which strategies work best can be really hard. I really like this comic on this slide because I feel like it captures what happens a lot of the time in the search space. We gather a lot of info about how our customers or users are using our search system, but we don't really know what to do with that data, which makes it effectively useless. Experiments help solve that problem by analyzing your data and drawing a conclusion to point you in the right direction. For example, on the previous slide, running the experiment gave us the insight that variant B is performing better than variant A by 14%. Now that you know that information, you can promote that variant or change variant A to look more like variant B or something, and thereby improve your search experiment. Experiments in Fusion 4 help you collect the relevant user behavior information and make that data actionable by giving you concrete information about what is working and what is not working in your environment. Before we go into the demo, I also want to spend some time on the terminology we use when talking experiments in Fusion. As you can see on the previous two slides, we use the words variant and metric to describe our experiments. And so let's go into detail about variants first. What is a variant? A variant is just the thing you're changing. It's essentially what you're trying to test in your experiment. So let's say you want to see how turning on recommendations impacts your users. You might have two variants. One is a search pipeline that has no recommendations, and one is a search pipeline that has recommendations. You would then deploy an experiment to see which of those two performs better according to some metric. In Fusion, we let you vary three things in setup. Pipeline, an example of varying a pipeline would be just what I just described with the recommendations. Collection, so maybe you have collection 1 that has title and author information as the main display fields, and collection 2 that only has title information, and you want to see which of those would perform better. You could vary the collection as a variant and determine which your users prefer. And finally, we also offer the params, which allows you to vary anything that you can do in Solr generically. In the UI, there's also a notion of a control variant. This is essentially the base variant, or the one you are interested in pairwise comparing all of the other variants against. Now that we've decided what to vary in our variant, how do we decide when one is better than the other? For this, we use metrics. What is a metric? It's essentially just the thing you're measuring. It's the user behavior you are measuring between variants to discover which is performing best. For example, if you're interested in which pipeline produces better click-through rate, you can use our CTR metric in the experiment setup. Fusion offers a whole host of metrics out of the box, like CTR, conversion rate, MRR, F1 score. And we also offer you the option to write a custom metric for your environment in SQL. The two metrics with a little bit of nuance to their implementation are our click-through rate metric and query relevance. Our click-through rate metric is computed cumulatively from the beginning of the experiment, which means when seeing the results, you should expect a plateauing behavior over time, unless you're seeing dramatic differences in CTR day to day. The query relevance metric computes things like F1 score and positional MRR against a ground truth set of queries. And if you don't have that ground truth set of queries, Fusion gives you the option to generate it out of your collected signals. For more detailed information on all of the metrics, I recommend reading the Fusion documentation. The last thing I want to talk about before we go into the demo is Trafficway. This is another really important part of experiments. Essentially, traffic is a percentage of users that get routed to each variant. So in this picture, 50% of users are going to the red variant and 50% are going to the green variant. Fusion lets you set the percentage of users using ratios between the variants. It's important to note, and we'll go over this in the demo as well, that the traffic routing in Fusion's experimentation setup is consistent. What that means is when a user comes into an experiment, their user ID will get hashed and saved. So any subsequent time they interact with your search engine, they'll be placed into that same experiment variant. This ensures that users will not see different search results depending on which variant they're placed into in the search session on your website. Every time a user comes in, they'll be placed into the same variant. So now that we've kind of gone over a lot of the terminology and given a little bit of background about what experiments are and why they're important, I'm going to do a quick demo for you. So get out of this presentation and head over to my demo screen. So this is what Fusion 4 kind of looks like. When you first enter, you'll probably see something like this launch screen, and you'll see that I have two apps already set up. The one we're going to be looking at is the Best Buy app. And let's just start by taking a look at our data. I'm going to head over to Query Workbench. This is kind of my default, the default pipeline that Fusion provides you with. And my data looks like album data or just generic Best Buy data, product catalog data. So I'm going to try executing a search. I'm going to search for an iPhone case. You'll see this, it's just putting the IDs on the top right now, but Fusion makes it pretty easy to change that. So I'm going to change name. And so I searched for iPhone case, and the first thing to come up in this particular pipeline is a Platinum case, a Platinum Series case with holster for iPhone 4 and 4S. So that seems like a reasonable result. In fact, most of these seem pretty reasonable, right? And so if you look at what's actually happening in this pipeline on the left-hand side, we've got a couple things going on. We've got a query field stage that sets what you see, field facet, this is if you want to add facets in an executed Solr query, And the first thing that's happening is this boost with signal stage. What a boost with signal stage does is it analyzes your user behavior under the hood and then boosts documents that get clicked on more often. And so what that implies is that the reason that Platinum Series is appearing at the top here might be because it's being clicked on more often than maybe the Hello Kitty gel case for Apple. So let's see what happens when we disable this stage. Now we have completely different results, right? And the top 10 results are almost 100% different. And what that means is when you turn on signals, these clicks are changing the results that we're seeing. But how do you know which is better? It's easy to guess that maybe the boost with signal stage reflects the behavior your users want to see, but it's hard to know that for sure. And both of these results seem perfectly reasonable for the Query iPhone case. It's entirely possible that an iClear polycarbonate case for iPhone is a valid top result, and it's also entirely possible that a Platinum Series is a valid result. So Fusion gives you a couple of things you can do to analyze the differences between pipelines. There's this great compare tool. So if I hit compare, I can, again, just pick the display field to be name. And I can choose a different pipeline here. So I have one set up where the signal stage is disabled. And you can see side by side what the differences in the top results are. And this is great for individual queries, right? I can search for something like laptop battery and see, if there are different results. The top result is the same, but the second is different. But this isn't a really scalable solution. You can compare single queries, and if you have the time to sit here and search for 10,000 queries and compare each one, that's great. But that doesn't seem like it would really scale. So how do we decide which of these two pipelines is better? Using an experiment. So I'm actually going to go ahead and walk you guys through how I would set up an experiment to test whether turning on signals is going to improve my click-through rate for this particular search system. This is a query workbench. If we navigate over to this little pie on the left-hand side, you can see there's a little experiments button, and that will take you to what we call the experiments manager. I have a running experiment that we'll take a look at later, but for now, let's start with a new one. I'm going to call this signals test. This unique ID parameter, this is what I was talking about when we talked about traffic weight. This is the value that gets hashed under the hood to ensure that when a person hits the appropriate endpoint for this experiment, they're going to be put into the same variant every single time. So let's just add a quick description. Testing whether turning on signals improves click-through rate. And let's take a look at our variants. So to start, we want to vary our pipeline. And so the control variant is I'm going to choose the one with no signals as our control. And then I'm going to add one more variant, call this one signals, and choose a query pipeline that does use signals. And you can see on the left-hand side, this is the traffic weight ratio that I was talking about. So let's say for now, we are deploying with signals. So let's make sure that the majority of our users remain in the same search experience, and let's only put 30% of our users into this signals experiment. So I'm going to choose 2 to 1, and that means 66% of my incoming users are going to be routed to the no signals variant, and 33% are going to be routed to the signals variant. Now let's go through and add a metric. We are interested in measuring click-through rates. I'm just going to call this CTR. And this primary denotion is just the first thing that you'll see when you actually see the reporting on the experiment. So I'm going to pick this as my primary metric. And just for fun, I'm going to throw in maybe conversion. Actually, let's throw in MRR instead. So now I have these two metrics and these two variants, and so I'm going to hit save. Now, we have an experiment that's saved, but this isn't actually collecting any data yet. And the reason for that is under the hood, this configuration has been saved, but there's no endpoint attached to this experiment where I should be routing my user. And so to create that endpoint, Fusion offers you two ways to link experiments with an API endpoint. You can either link to a query profile or to a query pipeline. And so we recommend that you use the query profile approach just because it's a little bit cleaner and a little bit more obfuscated, and that's the one I'm going to take you through right now. I'm going to head to the query profiles endpoint, and I have two query profiles. So I've got Best Buy, which is my base profile, and then this is the second one that I've set up called Signal Profile. So I'm going to use this one, and I'm actually going, so what this allows you to do is when you first create a profile, you'll see this Enable Experimentation button. Clicking it allows you to select an experiment ID to attach to this query profile. So in this case, we're going to use Signals Test. Then scrolling down to the bottom, you can see this API endpoint is what your users will need to hit in order to be placed into this experiment. So what that means is anytime a user searches using this API endpoint, 66% of users will see the results using the no signals pipeline, and 33% of users will see the results using the signals pipeline. And their clicks, depending on which variant they're in, will be put into our signals collection automatically and analyzed for you to see the results. So now that I have experimentation enabled, I'm going to hit Save. That's going to save the experiment to this particular query profile, and then you can hit Run. One thing I want to show before we run this experiment is a cool thing about the query profiles implementation is, let's say I don't want to use either of these experiments. You can actually add an experiment in the same way that we just did from this UI. But since we already have one set up, I'm just going to switch over to that one, hit Save one more time to make sure, and then hit Run Experiment. And now what's happening is, like I said before, anytime a user hits this, searches using this API, they'll be placed into the appropriate variant, and these metrics will be getting calculated under the hood. One thing that's important to remember is once you hit that Run Experiment button, you should not be changing any of the things that are associated with the experiment. You should not be changing the query pipeline that are involved in your variant, because that will invalidate the integrity of your experiment. And the experiment manager will not allow you to change any of these parameters once you've started running the experiment. So now let's go take a look at what the results are. There's a couple of ways to get to the results. You can either go directly through the manager. If I open, you can hit Experiment Results, or if you navigate back to the Analytics pane and click on App Insights, you'll come into our Insights reporting tool, and then the navigation pane on the very bottom with this little flask is Experiment Results. So I'm going to head over there. At the top, you have to select which experiment you're interested in. So I'm interested in seeing the results for Signals Test. And you can also select which run of the experiment you are interested in seeing the results of. So what this corresponds to is when we are computing the metrics under the hood, those are effectively jobs being run in the Fusion backend. These are the results of those timestamp jobs. So as you can see, we don't have any results because I just created the experiment, and it doesn't have enough signal data coming into that particular endpoint to give you any valuable information. But I do have another experiment that I had been running for a while called Rex Experiment, so let's take a look at that one. And here you can see that, one, we have statistically significant data, which means that enough users have come into the API endpoint that is associated with this experiment and have clicked and have interacted with the system to be able to draw some conclusion from the data that we're seeing in the chart. So this particular experiment just has click-through rate, and it's only been running, it's only ran for a few days. But we can really quickly see that the recommendations pipeline that we're using is performing much better than the control pipeline. And so we can go and make that data actionable by going back to our system, maybe deleting the control pipeline or converting the recommendations pipeline to the control, or even upweighting the recommendations pipeline so still more of our users see those results, which are clearly performing better. And yeah, that's kind of our basic run through of what experiments look like in Fusion. I'm going to hand it back to Andy Oliver for our wrap up.
Thanks, Lasya. So to learn more, please check out our blog via the link above. If you're wondering what kinds of improvements you may need to do based on your A/B test, check out my colleague's previously recorded webinar, Fusion 4 Head and Tail Analysis. If you guys have questions, please go ahead and enter them into the tool. There's a place in the conference tool for questions, and we'll do our best to answer them. If we don't get to them, then we'll have somebody else reach out to you offline and try and answer those questions. Finally, to learn more about Fusion 4, please check out our recording of a previous webinar of a Fusion 4 overview. Also, stay tuned for future webinar announcements. So thank you, everyone, and we'll be happy to answer questions. We do have one question already, and the question is, how are results ranked by default? Is there any relevance ranking method? I can field that if you like. By default, they're going to be ranked using in Fusion, they're going to be ranked using the default Solr query ranking, which is a variant of TF-IDF, which is term frequency minus inverse document frequency, called BM25. And you can actually Google BM25 on Wikipedia, and it'll kind of give you an overall of that. But basically, how frequently the term occurs in a document minus how frequent it occurs in all of your documents. And that makes that particular document more relevant. BM25 just optimizes that and flattens it out. So just occurring 10 times more often doesn't necessarily make the document 10 times more relevant after a point. And so that's the default ranking method, ignorant of how users are actually looking at something. The downside to that is that something that says for iPhone is probably actually not the iPhone. So if I were searching for iPhone, the word iPhone will occur more frequently in an accessory for an iPhone than in the iPhone itself. So there can be downsides to that and come up in a corpus. So we have another question. The documentation on the signals API says we need to include a parameter on our click signals to tie the signal to a query response signal. Is this linkage something used by experiments? If so, how does it work?
Yes, so that linkage is used by experiments. And so, like I was saying when we were explaining the traffic weight, there is a parameter in the experiment called the user ID. And what is happening is when a user comes into that particular endpoint, whether it's at the end of a pipeline or whether it's at the end of a profile, that user ID gets hashed within and saved within our signals. And so anytime a user comes into a new experiment, they'll always be placed into the same variant based on that user ID. Then what happens is their actions on the page get saved into our signals database. And so that's the onus for that is on the user to configure the signals to send whatever behavior you think is relevant back to our signals API endpoint. Under the hood, after a certain number of signals have been collected, our jobs framework associated with the experiment will compute metrics based on those jobs. So for example, with click-through rate, a user, let's say user X comes into the API endpoint and clicks on the first, the second, and the third results that they see on variant 1. Then after a certain amount of time has passed and the job has run, that information will be aggregated, and we'll see basically for variant 1, 10 users have clicked on the first 3 results. And for variant 2, no users clicked on the first 3 results. And you can use that information to make your data actionable, kind of how I was talking about before, and say, you know, variant 1 is performing better than variant 2 in this particular case.
All right, so we have another question. You showed how to configure an experiment in the generated endpoint URL. Does this mean that the consuming website and application must reintegrate against the new endpoint URL in order to run the experiment, or is there a way to provide a stable integration endpoint to these consuming apps and run ongoing experiments underneath without reintegration work?
Yeah, so that's what's really cool about query profiles, right, is since you can link a query profile with an experiment, or a query profile can possibly not have an experiment attached to it, it actually doesn't require any further integration work. So let's say you set up your website to point to query profile A. That API endpoint doesn't change even if you enable experimentation or don't enable experimentation under the hood, which means that it's just a matter of hitting that one enable experimentation button and configuring your experiment to place your users into an experiment to begin with. So there's no additional API level change necessary if you choose to go the query profile route. If you choose to go the query pipeline route and attach your experiment to a query pipeline, you will have to change the API endpoint to point to that new pipeline that's associated with the experiment. But the profiles abstraction kind of hides all of that under the hood.
Next question. Can we do A/B testing of different Solr search field weightage and boosting weightage? For instance, A/B testing of edismax parser values for BF and QF parameters, the values we search and its weightage. And are there other ways to measure search relevancy with A/B testing with Fusion?
Yes. So to answer the first part of that question, as I said in the slides, there's a param. So I showed you can vary three things, right? So you can choose to vary the pipeline, you can choose to vary the collection, or you can choose to vary Solr params. So that means that if you're more comfortable, using Solr params and you want to vary edismax versus dismax, for example, you can directly set that parameter inside of the experimentation setup by selecting query param, by selecting Solr param as the thing that gets varied, and then specifying edismax and dismax in your variance. So yes, anything you can do in Solr, you can vary in our experimentation framework. And then to answer the second part of your question, the metrics that we offer out of the box are CTR, conversion rate, MRR, and query relevance. And we also give you the chance to write anything custom. So if you're interested in some signal aggregation strategy that's unique to your environment, you're able to do that with SQL as well within the framework. So it's pretty extensible in terms of measuring the relevancy of different variants.
All right. Are there banded algorithms in our current implementation?
Yeah, that's a really good question. We don't have bandits as of right now, but they'll be coming in the next iteration of experiments.
All right. How do you calculate the results for the CTR metric?
Yeah, so that's a really good question. As I was saying before, the way that we calculate the results of CTR is a little bit counterintuitive. And so what the job is doing under the hood is it's computing essentially the number of clicks per variant from the beginning of the experiment. So let's say you launch the experiment on day 1. And on day 1, variant 1 performs way, way better than variant 2. And then on day 2, variant 1 performs a little bit less better. And then on day 3, variant 2 performs better than variant 1. Since we're computing CTR under the hood from the beginning of the experiment, you will pretty much see a stable line after you've started collecting enough data where variant 1 emerges as the dominant winner. And that's good because that means any dramatic changes, any changes that would cause you to maybe flip a variant or make a change in your environment will have to be dramatic. But it can also be misleading from the graph because it's not giving you day-to-day information. It's giving you information from the very, very beginning of the experiment, if that makes sense. And so to talk a little bit about what's actually happening with the calculation, essentially what we're doing is we're counting the number of times a user clicks on a result according to the variant. Very simply put, that's what's happening in the click-through rate metric.
All right, related to that, are you using multivariate algorithms to compare variants in an experiment?
No. So as of right now, we're actually doing pairwise comparison against the control. So it's not like if you have a 3-variant experiment, you're going to be doing control variant 1, control variant 2, variant 1, variant 2. We're actually just doing the comparison between control variant 1 and control and variant 2.
All right. Well, we are right at after the half of the hour. Any questions we didn't get to, we'll answer offline, and somebody will follow up with you, so watch for that. Thank you guys for attending. Please stay tuned for future webinars, and check out our blog. We just actually posted a really interesting image search post about how to integrate Google Vision into Fusion. Anyhow, thank you all for attending, and we'll see you next time.